Hello, everyone, and thanks for joining us. My name is Ali Al-Sharif, and I'm a steering committee member at ACE. ACE is a global community of machine learning practitioners and researchers who have gathered around topics in AI engineering, research, and products. We have a repository of YouTube videos that showcase authors presenting the research and practitioners demonstrating the use of emerging machine learning methods and tools. We also host social events where you get a chance to network with fellow community members. We conduct workshops focused on helping participants take machine learning concepts from foundational theory all the way to fully deployed models. We have multiple streams organized around specific topics, and this presentation is part of our AI product stream. We encourage you all to subscribe to our YouTube channel and check out our website at ai.science. Today, we are hosting Ashley Beattie. Ashley is a steering committee member at ACE as well, and he is the head of DevOps transformations at Agile by Design, where he helps clients realize breakthroughs in organizational and team effectiveness. Ashley also works part-time as a naval reservist with the Royal Canadian Navy. Thank you for your service. Ashley successfully launched a number of AI products in the area of marketing and advertising optimization. He received his MBA from McMaster University, majoring in management of innovation and new technology. Before I turn it over to Ashley, I will briefly share with you the motivation for his talk. In an earlier session, Ashley presented the AI Canvas and how it could be used to support a systematic evaluation of AI projects. Today is a continuation of AI project evaluation stream. He is going to be presenting us the an AI project evaluation from a financial investment perspective. It is a very interesting presentation, and I'm looking forward to it. To the audience, please post your questions in the chat, and we will be asking your questions immediately after the presentation. So without further ado, I will now turn over the presentation to Ashley. Please take it away, defining your AI value model. Ashley Beattie, go ahead.
Thank you very much, and really looking forward to having this conversation with you. And as Ali said, if you have any questions, please do post them in the chat, and we'll get to them. Additionally, it serves that there's context behind this presentation that was in the first presentation, and while I'll cover it lightly, I highly recommend taking a look at that. Think of the defining of your AI value model as another step in the process to adding certainty of success into your AI initiative. So if I zoom out really far, there's a great quote in this AI in Europe report from 2018 that says, AI is still a highly abstract topic for many when it comes to proving day-to-day business value. And it's kind of funny because if you look at where things were at in 2018, the investment profile looks something like this, where 60-odd% are under $50 million a year of investment, but there are quite a few that are spending quite a lot on AI. And this was a survey, I think, of about 500 Fortune 500 companies. And that was 2018. So remember, it was a bit of an abstract topic then. 2019, more investment. And what we're seeing is that people have moved from this cautious exploration to legitimate investment. $500 million is a lot of money. $50 million is a lot of money. So the challenge when you start investing this kind of money is actually getting the ROI out of the investment. And there's a really great company here in Toronto and across Canada, Element AI, that has this AI adoption, call it process or model in view. And what they were saying is that about 80% of the companies, i.e. these here and these here, are in this early stage of AI exploration. So they're either exploring or they're doing experimentation, whereas the remaining 20 or so percent have actually got a formal process. And over the next couple of years, we're going to see a migration of those into the formalization and upward stages. And if I kind of zoom ahead to that stage 3, where these 14% are and where these others are going to come, it says something to the effect of this. So they're going to be piloting AI solutions and aligning the organization to move ahead. And they're going to be doing, limited pilots of sorts. But let's take a look at this sentence here. So putting AI solutions into production requires significant effort at this stage. So each solution must have a clear business case with agreed upon performance metrics. Clear business case and performance metrics. Now, sometimes the more sciencey side of us as AI developers don't always think in these terms. And therefore, I'm going to introduce these two goals to the talk, right? Which are, one, about this business case, how can we do a structured, thinking around the value of this initiative that we're about to develop. And then on top of that, what metrics are we actually going to have to reach to realize the business value being expected? So the business case and the metrics. So to kind of go a little bit down this path, what is a value model? So think of it as how your business converts its inputs into outcomes and creates value, okay? So it's that structured representation. And why have one? Well, not only do we want to make sure that we've got something that we could apply this, conversion to and generate value, we'll know what kind of return on investment to expect out of it. And we will baseline this versus other initiatives we've been part of or other initiatives that the company has done. We also will use this as this device to communicate where we're actually expecting to generate value and surface the assumptions around it. If we know our ROI is in line with things we've seen before, we're probably not undertaking something that is crazy. But if you expect a massive ROI versus other things, we're going to have conversations about it. And the companies that are, thinking like this are largely going to expect that. So when it comes to AI systems, what does this input to outcome formula look like? Well, it looks like this. And this is leveraging some of the stuff from the first talk, so I recommend you take a look at that. But in essence, you have events that happen upon which you make predictions. And then based on that prediction, you will determine whether to go to A or B, and then you will pursue that action. And in this case, the key value driver of the outcome is the prediction. So if I'm making really, really, really good assessments of my situation, I will make really, really good judgments, and then I will pursue more valuable actions. And AI is all about the quality of this prediction. So if this prediction quality is so important, how can I baseline the present value of that quality, right? How can I know how much value I'm going to get from the prediction quality and any change to it? And then how can I baseline that to evaluate whether I'm actually going to make money? And we don't really talk about that much on the technical side of things, but in the business world, we have an old friend. And as a business guy myself, I'm very familiar with this topic called net present value. Okay, it's a really, really interesting way of assessing the value of an investment. And the way it works is something like this. So think of this graph here on the right-hand side as the investment profile of a mine. So I'm building a gold mine. And the time axis here indicates that for the first little while, I invest a lot of money in the gold mine. So I go well into the negative. And this is the time when I'm building, I'm digging the hole and I'm getting the equipment, I'm building the people's, skills and whatnot. And at this point here, I start finding gold, okay? And therefore, I start paying off the investment. And I start getting positive cash flows up until the point that I pay off the investment. This is my payback point. And then to the right, it means that my cash flows are positive. And think of it like this, that in this area of the graph, the net present value is negative. I've spent more money than I can make. And in this case, the value is positive. And at this point here is when the net present value is 0, when I cross the x-axis here. And that's when the investment breaks even. We can apply this exact same approach to AI. And I'm going to call this net present value of your future prediction quality. And it's a fancy way of saying, let's do net present value for AI. So same graph. Instead of a mine, we're talking about an AI investment. And at the first stage here, similar to your mine, you have to invest in developing the capability, okay? So this is where I'm spending money. I'm not making anything. And obviously, I'm making negative money in this case, as the model hasn't been value implemented and I haven't actually deployed it. Now, once I've deployed it, here is when I can start making money, but hopefully I reach a threshold value at which the value is positive, i.e. when the model has been implemented and people are taking its recommendations and it's producing improvement on an old process or an old decisioning way of doing things. The slope of this line is a function of the scale, i.e. how many times and in how many areas is this model implemented, as well as what is the incremental value that I'm generating. So if I've got a really, really, really steep line, i.e. I climb really, really, really quickly, it means that my model is very, very valuable and it has a really, really positive return on its investment. And then, as I said earlier, the ideal situation here is that the area here over the time of your investment is less than the area on the right, okay? That's when you know you're profitable. So we're gonna leverage this same model for AI, and think about this when I'm gonna apply it to a couple of examples coming up. So here's how to do this. So first one, you have to get a really good feeling about where you're at right now. So how many predictions that I'm making, and how much does it cost me to predict? Every single time I make a prediction, how much does it cost? And what is my current rate of accuracy? And with that information, I can actually calculate the net present value. I can use the exact same formula that I showed you earlier. And in this case here, there are a couple of subtasks that you have to take that we're going to show in a bit, which is identify what you're optimizing for. So any increment in a certain metric will realize value. We have to identify that and figure out which one's actually going to be indicative of ROI. We're going to figure out how much we're going to spend. So at the end of the day, AI is not free, I think. They haven't done that yet. But if I'm going to spend money on AI, I've got to figure out, okay, in advance, I'm going to invest in this number of full-time employees, or this number of contractors, or this is the amount of money I'm going to spend on infrastructure. So you have to identify what your investment is. And then we're going to calculate our break-even point based on the movement in that metric, okay? So a lot of information. I'm just going to start taking you through two examples. And the first example is in a financial institution. I've got a call center, and they're going to apply an AI solution to optimize their call center effectiveness. Okay, this is a synthetic example. I've made it up, but it's kind of illustrative of the conditions and how to do it. On the right-hand side, the breast cancer test, this is a real example, and we're going to apply the real statistics that we find in the real world to identify at which point their AI solution breaks even. So the financial call center. So this is a large financial institution, and clients call in about 50,000 times a year to buy financial products. And in response to those phone calls, the call center rep looks up the profile or looks up any information they have on them, and then attempts to sell them some products. And his success rate looks something like this. So 7.5% of the time wins the deal. Okay, sells them some insurance. And the 92.5% of the time, no deal. Okay, didn't make any money. And just layering on a little bit, we're going to kind of craft our AI objective. So this is where I want you to go back to the first talk, which I introduced the structure of an AI mission statement. And in this case, it's pretty straightforward. That when when a client calls the support line, if the call operators could know which products clients were likely to buy, they would have an unfair advantage when pitching these products. And then they'd win more deals, indicated by increased revenue. The learning objective in this case is this prediction right here. If I could know which products clients were likely to buy, okay? I know that right now, my current success rate on this process is 7.25%, but I don't know what my desired success rate is. And that's really what I got to figure out. And I'm going to go in with some assumptions here. So the average cost per call, I've got $10. So this is baseline based on what you'll see when you do a Google search on what it costs, an all-in rate for a cost per call. So this is not only the person's salary, this is the telephone lines, this is all of those, call it peripheral adjacent requirements to make the calls happen. And then I'm going to say, you know what? I'm an FI. I'm going to invest in one full-time employee and some infrastructure, which is about $200,000 per year. So if I invest $200,000 and every single time it runs, it costs me $10, what is my desired success rate? What increment above 7.25% do I have to realize for this thing to start making money? Okay. So if I look at this, my animation looks a little bit funny here, but this is the graph. So remember that I said that we were going to spend $200,000 per year, okay? And this is if we break even at the end of year one. So this is a successful implementation that finishes in year one. What happens? Well, for the first year, I lose this $200,000, okay? So this green line is your net decisioning income. And at the end of the year one, I break even. So if that was actually the case, what would the number be? The number is, let me go ahead, is 8.51%. Recall that my previous accuracy was 7.5%. Okay. And if I reach 8.51% improvement in my call effectiveness owing to this AI implementation, I will have broken even. Okay. And this represents a 13.5% improvement over our baseline. So it's not just that 1% or 1.25% that looks good on paper. It's actually a material improvement of 13.5%. So you're going to have to make a substantial impact on the mathematics of this. But that's if you break even at the end, if you pay off at the end of year one. So if you reach 8.51 at year one, you're gonna break even. What happens in year two? Well, in year two, recall that I continue to invest, which means that I invest this $200,000 in year one, and I invest $200,000 in year two, which means that it requires a higher break even. Okay, so this means that it takes longer. I have to invest for longer, which means that my thing actually has to be more accurate. I've got to win even more deals than I do in my current state. So even though the break-even success is effectively 8.86%, this is now an 18.2% increase over what we were originally. So in short, the longer it takes for you to reach your objective, the more accurate or the more successful you're going to have to be to make up for the loss of investment. And this is a good perspective because you got to think, okay, so is it even possible for me to realize the investment's value in a short period of time? In most organizations, it takes about 2 years for something to go from zero to fully implemented, making a lot of money. If you're in an organization with shorter lead time, even if it takes a year, now everybody's using that AI decision support tool for the call center. It's probably a year is aggressive, but recall that that was still a 13% improvement. And this is the kind of business case input that you're going to provide to the business when you're going to ask for that $200,000. You're going to say, okay, we expect to break even at in the second year in this case at 8.86% versus our current 7.25 based on the original investment of $200,000. So hopefully that gives that 1 and 2. So is this a business caseable thing? Well, yes, I know. I'm asking the business to give me $200,000 and I'm going to give you this kind of an improvement. And the metric I'm looking to hit is a success rate of 8.86%. Going to move ahead to breast cancer detection. So this is a case where this is a real example. And the stats bear out that 1 in 8 women in North America will eventually contract breast cancer. That's really, really bad. The other really bad part of that is that if anybody that's actually diagnosed with cancer, okay, so these are people that are in this left-hand side of my confusion matrix, whose actual condition is that they do have breast cancer, 87% are diagnosed correctly. 87% of those are right in here. That means that this amount of people here are getting an incorrect diagnosis where the cancer is missed, and they're either they're not treated effectively. Even in this case here, right between here and here, so often people are treated, they're overtreated or undertreated based on what the diagnosis was. And there is actually a lot of money going into breast cancer detection. It's an image recognition challenge. And last year, about $20 million was spent on AI-based breast cancer detection initiatives. So of the 300,000 tests for breast cancer that happen every year, this is the general breakdown of how the true positives, false negatives, false positives, and true negatives materialize. Now, as a person is looking at the mathematics as well as looking at how the decision really takes effect, the person that we're really trying to help here is in the bottom left-hand corner, that we completely missed the diagnosis. And in this case, we suffered the loss of $500,000, which is the average malpractice suit requirement. That's where the economics are the most valuable. So using this as input, what we can do is we can make some assumptions of where we have to add value using AI. And here is how the objective looks. So the mission statement is when a mammogram is performed, that's how they do these diagnoses. If we could enable radiologists and treatment staff to correctly identify cancerous tumors, they would have an unfair advantage when applying these treatments earlier in the onset, thus enabling higher patient survival rates and reducing the cost of treatment. Okay, our goal is to reduce the false negatives, as I said previously. Okay, and our false negative rate is currently 1.63. So what number do we have to reach? If we're 1.63, we're going to try and reduce that number. Okay, so we're going to take our false negatives and turn them into true positives. And the average cost per prediction is $2,000. So this is how much it costs to actually apply a prediction. Okay, this is people's time. This is the machinery. The all-in cost is $2,000. And with that investment that I was saying earlier of $20 million per year, with a 3 years investment horizon, this is the kind of math we're looking at. Okay. We need to break even. The actual stuff to the left, and I'm sorry if you see 6.43 or 3.21. In effect, people won't implement the algorithm if it doesn't exceed the human's capability, especially in this case. And when the algorithm starts breaking even is when the false negatives fall to 1.61% versus the 1.63 currently. And the reason for this is because I don't pay as many malpractice suits. Okay, I also don't apply as many false useless treatments. So in essence, we would use this as a business case. So we would say, okay, for the $20 million invested, what we're expecting is that we will reduce our false negative rate from its current 1.61% to 1.63%. That's how you would actually produce this in a business case, so as to get the business buy-in for what you're investing. And this is how you also measure your effectiveness. So right now, the effectiveness of the algorithm is 0. Like we don't know what the actual false negative rate is. But after 1 year, what you're expecting is to follow a trend line of sorts down to 1.61. We also know that in AI, sometimes you have these magical breakthroughs. Sometimes those aren't as palatable to the business. So therefore, what you do also need to show is that you are trending downwards, or you're trending upwards towards the accuracy you're looking for, because you can also tie the information regarding accuracy to the information you've got from your investment on the same graph by that definition. So this is how, at a high level, you actually implement this. Net present value is not a magical science. There's an Excel formula that you can apply. I'm also going to share a link when I've cleaned up the Excel spreadsheet a little bit for this on my GitHub. So stand by, and if you're interested in this model, please put your email into the chat, and we'll definitely get it to you in short order. I want to wrap up with some final thoughts here. So no matter what, the map, i.e. your model, is not the territory. The model and reality are not the same. And this map that you will produce at the outset to create your business case is just a starting point. There are still a lot of assumptions in it. And what I want you to do is, in follow-on work in your design sprint or your process of learning about the situation you're dealing with, you validate them. So validate how much you're going to invest. Validate that your accuracy targets are are reasonable. The other thing you might validate during your design sprint is that in order to realize that small change, you don't actually need an AI solution. You only need to make a process change. So I want you to actually go through that process after you've got this target state, okay? The second thing is that I want you to spend the time to think about what you're looking to optimize. So in the first case, I wanted to optimize the ability for the call center rep to be effective, okay? So that is a different type of optimization than in the second one, which is I'm actually trying to minimize the false negatives. And by looking at it through this lens, you can really focus on the numbers or the metrics that'll directionally give your initiative the guidance to get to where it needs to be. It also helps socialize how you're going to know whether you're on track. And that is really, really useful, especially as companies start manifesting these as beyond pilot things. So as I said at the very beginning of the presentation, we've moved from this conceptual proof of concept phase to like, we're actually doing this. It has to have a business case. So you have to know what you're optimizing for. The last thing I want to just leave with you with is that I want you to make sure you're thinking through the second order effects of implementing these things. So if you could do this, it would also mean something else, okay? So what is the change in radiology? What is the change in that space that you're, in a way, disrupting using this artificial intelligence? Because that might also indicate a fundamental reworking of the value stream. And it's at this stage, before you go and build it, that you want to think those things through. So what does a false negative rate of 1.61 actually look like? And asking people in the area around you might have some new insights, which is if we got it to 1.61, it would mean that this was an opportunity, or we could get a better deal on insurance. There's a lot of other things we want you to think through. So in all, that's where we're at. And I'd really like you to give me any feedback, or also, any questions you have would be, really, really, really appreciated. Thank you.
Thank you, Ashley, for that great presentation. And we will now start the question and answer portion of the session. The first question that we received here is, what makes this value model different if it is not about AI value? Example, some other type of technology, if we go back 15 years, like implementing the cloud when there was previously no cloud environment. So maybe what's so different about this value model that's unique to AI is maybe the question.
The uniqueness piece here is actually in the confusion matrix. So you're right. In a lot of cases, you're using the same math. Net present value isn't new, but if you look online, you won't see net present value in AI. And it's because they haven't introduced that value of the prediction, and the change in the prediction accuracy or the reduction in the false negative rate to really drive the decision. Because the thing that you're getting the more value from in this case versus the cloud, it was like an operational effectiveness play. It was operational efficiencies play. Okay, so we're going to spend the lower total cost of ownership of infrastructure. Well, that's a measurable that you just measure in the number of computers. It's really clear in that case. But in AI, it's all about that connection between the prediction and the accuracy, or the metric around that prediction, and the value that's generated. So it's just an extension of the same model more than anything else, but making it as a function of that decision quality. I hope that answers the question.
I think it does, and if not, I think it was John that asked the question. He can do a follow-up. Now, the second question we received from John here is, how does this model cater for unknown factors? Example, the black swan that we had this year called COVID. So how does the model account for uncertainty, things that were not part of the original forecasts?
So this kind of goes back to what I was saying a little while ago about the model has assumptions baked into it. You definitely want to validate the assumptions inside the model, and you want to de-risk a lot of those assumptions. If you're going to get blindsided by a black swan, like it's not always whether the value could be generated or not. It kind of just like turns the table over on whether this was the whole world changed. So you have to revisit the assumptions underneath it if you decide to continue. So in the case of like, let's just think of a disruptor like on breast cancer. Let's just say that somebody figures out that you can drink this magic drink and all of a sudden the breast cancer goes away. Well, if that was the black swan that was part of this model, well, do you even want to do it anymore? I think would be the first question. The second question is like, what accuracy do we need to hit now? I think it still deserves a bit of time to think about the change that it makes to the assumptions that underlie the model. And then you just recalculate. You just go, okay, well, now instead of hitting 1.61, we have to hit, I don't know, 0.03. Uh-oh. Is that possible? Like that's why you have the conversation now, rather than just continuing to write code or continuing to build models and continuing to train stuff. because it just may be that it's completely economically inviable. It could happen in the opposite way too, right? Like it's just the map of where you're hoping to be and selling your map.
Okay, Ashley, thank you for that answer. Now, I also have another question here. So, in the pharmaceutical industry, for example, in order to develop a few successful drugs, you need to have a large number of initiatives and tolerate a high failure rate. And essentially, the few successful projects that make it through the pipeline make up for the large number of failures that went nowhere. So how would you apply this financial analysis to a portfolio of projects versus a single project that's evaluated on its own?
Good question. Okay, so there are, I can think of two different modifications you want to make here. Mm-hmm. So for one, you're gonna drastically change. In the case of drug discovery, it's like, I think it's like 10,000 to 1. I think you have to look at 10,000 molecules to get one success. So think of that as being like your true positive rate. And then you have to fill in your confusion matrix for all of the other ones, right? So how do you assess what a false positive looks like? Well, that's probably one that kind of got through, but it wasn't actually a viable molecule. So you're still going to do the exact same math. But the other thing about the pharmaceutical industry, which requires a bit of visitation here, is that your investment horizon is much longer. So you're definitely not going to break through in year 2. You're going to break through in year 8. Now, that said, let's just pretend that your AI model figures it out faster. It finds a viable candidate in year 2. Well, that is still a viable candidate, and it now accelerates your way to get through the break even, because now I can maybe accelerate it through some of these institutional checks that expect it to hit a certain degree of call it readiness more than anything else. And I'm happy to walk anybody through the model and assumptions, because it's just a matter of altering those two parameters. Drug discovery, in the case of having a portfolio of drugs, though, what you may end up also doing is you might also end up creating multiple models. Because if I've got a drug for, I don't know, this kind of breast cancer, and then I got this drug for this like neuro thing, and then I've got this other drug to monitor like heart pressure or something, or fix my heart pressure, I might develop a net present value model for that one, and then one for here and one for here, because I don't think that the domains bleed that nicely. There are also ways, and it's almost like doing like a portfolio of net present value to stack them together, but it's also depending on your business. Does your business think of them as being stacked, or does the business think of them as having independent business lines associated with the AI implementation for the breast cancer drug, for the neurological drug, and for the blood pressure drug? But great question. I do think it applies. You're just going to have to play with the parameters a little bit.
Okay. So maybe another question here is, if we're strictly evaluating projects based on financial metrics, could we be potentially just giving up on innovation and trying things that we don't know the answers to ahead of time, because they're just not going to fit nicely into a net present value formula?
Oh, definitely. And like, I feel like the project office is where innovation goes to die, because like it's exactly this. There is spurious value in experimentation that doesn't always translate into business value. But this is also the corporation's control functions coming in. The opportunity to try all the crazy things was in the earlier phases, and now as real money, like $500 million. Like, I don't think there's a company in the world that's just throwing that at an innovation shop and saying, do whatever you want. Well, maybe Google X does that, but I even think that they will have some form of a target to reach. So yes, it it is likely we will miss out on innovation. Yes. This might also be the opportunity for unfortunately, I think I was going to say that the startups out there that don't necessarily have the same risk profile or the controls in place might be where these, call it, exponential innovations find their way out. But that's also a challenge, given that a lot of the tooling and data doesn't always exist in the startup world. So innovation is a two-edged sword. I would really, really hope that every company has a moonshot fund of sorts, but Fortune 500s also do need to report on what they're spending money on, and the board will expect a certain degree of understanding of what they expect to get out of such a massive investment. So I would hope, that there are people who are working with this little project on the side to bring those out, but even that might end up being business case at some point.
Yeah, and maybe tell me if you agree here. I mean, it seems that where we're heading down the path where we're having these structured financial analysis, where we're going to have well-defined objectives before we even start, and it's really steering us towards using AI tools that have been proven and demonstrated in many domains, and we're now just applying them as part of a project versus doing something experimental where we're discovering that we can do something we did not know that was possible before. Do you agree with that?
Yeah, I do. And I think that that's also a function of where the industry is at. 20 years ago, when a lot of this was way less figured out, it meant that people had to really get experimental with it. But now, like, think of what AutoML does. It's pretty incredible that you can just throw your data at something and it'll try and figure it out. And therefore, I do think that the industry has largely solved or has frameworks and structures around classes of problems that mean that we don't have to reinvent, things to figure them out. And it will continue to go in that direction as we apply this general purpose tool to other spaces. There are definitely, call it, areas of opportunity that will require experimental development and a lot of scientific research. And I'm obviously not in tune with all the things that are happening, quantum and all these other like magical places that I just don't really understand that well. But this is almost like the curve of innovation adoption, that what was once experimental and crazy turned into the thing that we did every single day. And I think that that's just going to keep happening. And therefore, I think that in a way, structure is beneficial because it prevents, it saves us from having to keep doing the same thing over again and over and over again and figuring things out that have already been solved. Probably makes it drastically increases your success rate, in my opinion.
Yeah, I assume you agree that there are some problems that are just better suited for startups that are not restricted by having to adhere to these well-defined financial analysis, and they're willing to take a chance, and that's probably where some of those experimental ideas need to happen.
Even still, I don't think it hurts to do the Excel exercise to really get a feeling for where you're sitting here. It probably takes you 10 minutes to just lay out your net present value assumptions and say, okay, well, imagine we had a miracle and we say, let's solve this in 6 months. Okay, we would have to hit this accuracy. Okay. Or, oh, wow, that's not going to be easy. And you would probably compare yourself versus the industry baselines just to know where you sit. And in the case of a lot of these investments, I don't think that degree of due diligence is performed at the front end of a project. And the cost of a couple of hours with a spreadsheet might de-risk the next 6 months of futile, effort that you've applied to something that was largely impossible or just was a little bit beyond what your company could invest in to do. So I feel like it's a pretty good return on effort to not start a project that's impossible. And hopefully, if you do that once, you massively succeeded.
And there's I agree, actually. There's absolutely, you could have another extreme of just saying, I'm not going to even attempt to do market analysis and financially evaluate the merits of my product. I'm just going to start coding, and if I'm lucky, then I'll do well.
Mm-hmm.
So that's certainly another extreme. I think I'm just looking around here. It seems that is the end of our questions here. Do you have any final thoughts before we wrap up that you would like to share with us?
Yeah. So first off, like, think of this as the time before you write code. That the best code that you write is the stuff that you don't have to write. So use these, these early phases, i.e. the AI canvas and the AI value model. And then we're going to do a talk in a little bit, or you're going to see a talk in a little bit around the AI design sprint. Like, use these for what they are, which is, I want to find out all my assumptions and I want to de-risk my project before I get really committed to the problem in a way. And once again, these are just assumptions. These are just ideas that allow you to ground your project in reality. And I look forward to hearing people's thoughts on, where they've been able to apply this or where it was challenged, because AI economics is new. To the earlier commenter's point on this being a black swan, AI is a black swan technology. It came out of it's been coming for a while, but now it stands to disrupt everything. We're going to definitely see new economic tools applied to this, where previous ones didn't necessarily capture the real, when you apply them, don't capture the value. So I would say this is definitely a work in progress, and it's an interesting field, and I'm really, really looking forward to seeing where it goes next. But also, thank you very much for joining. That was really great. Thank you.
Okay, so to summarize before we close here, Ashley presented the AI value model and helped us just get a better understanding of financial evaluation methods and thinking of an AI project. I thank Ashley for a great presentation, and I thank all who joined us online. To see more free content like this, please visit our website at ai.science and log in to access slides from this and other sessions. Also, make sure to subscribe to our YouTube channel, ML Papers Explained, to get notified about all live sessions and other free content we publish. This concludes our event. Thank you for watching.
Thanks, everyone.